Hello guys, in today's video we would be creating a REST API service, a MCP service and a chatbot which interacts with your APIs using MCP service. So let us first understand what exactly is a MCP server. Okay, so you might have worked with web application where you have integrated with the REST APIs and front ends, right? But nowadays everyone is using chatbots. So let me share one example. If you are interacting with ChatGPT and you say to ChatGPT that provide me information about X topic, then it can provide you. But if you assign a task to ChatGPT, go to Airbnb site and book me a hotel in Goa under 5,000 per day and book it for 3 days, can ChatGPT do it? No, it cannot do it because it is just a language model. It it cannot perform actions on your behalf. Okay, so up till now what used to happen, there were web applications, you have front end applications, and you have buttons and those kind of things where a user can select from the drop down, click on submit button, and then the bookings would be done. Okay, but eventually if you look what was happening under the hood, all those data was getting collected, which was provided by you in the input boxes and drop downs, and based on that data, that was passed to the REST API servers using HTTP protocols, right? So that's how your booking was done up till now. But now what we would be doing, we would be enabling a chatbot to make these API calls. Okay, so basically how we do it, you will ask, Durgesh, tell me, explain me how I can enable a chatbot to make API calls. So yes, so first thing is we need to create MCP servers. MCP is basically model context protocol, where model is basically your LLM model, context is basically uh, information around the tools, okay, which we would be interacting with, and this is a protocol, a model context protocol, like a HTTP protocol. Okay, okay, so let's now see uh, how we are moving from REST APIs to model context protocol, and how this MCP is being used by the chatbot. Okay, so what is MCP? It is basically a JSON RCP based remote RPC, remote procedural call based protocol, which would be a wrapper around your REST APIs. I'm giving an example of REST APIs. You can create this MCP wrapper around CLI tools as well. Okay. So for our current demo, let's take an example of REST API based MCP wrappers. Okay. So let's, for example, take a REST API server for a to-do application, where basically that REST API server enables you to create any to-do, delete any to-do, update any to-do. Okay, to-do is basically your to-do list item. Okay, so you have this REST APIs, and after that, what you do, you create another server, which is your MCP server. For this, you need to install MCP library, and after this, you need to create wrapper tools for each of those endpoint. Like you have a create endpoint, you have a delete endpoint, you have a update endpoint. Okay, for these three endpoints, you create three different tools are basically MCP functions, and these functions are wrappers which will make HTTP calls to the endpoints. Okay, so so now, for example, just assume that you have created three functions, and each of these three functions make a HTTP API call to the actual REST API service. Okay, now how to move ahead? Now we have created, you will say that, Durgesh, okay, fine, I have created a function wrapper around these API calls. Now what? So now using this MCP library, we expose a port, and this port will be connected to our chatbot service. Okay, chatbot will interact with the MCP server. It will first connect to the MCP server, and it will say, give me all the list of tools that you have. Okay, so it will give you three tools, which is get, update, and delete a to do. and it will also have a description of those functions. Like, for example, every function has a doc string, correct, which basically describes what that function does. So similarly, all these tools have a descriptions associated with it. These descriptions are provided so that a LLM can understand which functions does what functionality. Okay. So the MCP client will first get the list of all the tools from the MCP server along with the descriptions, and it will basically create a JSON format, a list of JSON. Okay. It is a standardized format which the LLM would find easy to understand. Like that JSON structure will basically contain the name of the tool, what is the description of that tool, and what all parameters it accepts. Like while creating a to do, it needs a title for to do and a description for to do. So these are the parameters of that function. Okay. So similarly for those three tools, we have now a list of three dictionaries or JSONs which we would provide to the LLM. Okay. Okay. So now you say, Durgesh, fine. We have created REST API services. We have created wrapper functions, which you basically call MCP tools. And we have exported it using MCP library on a particular port number. And after that, we have created a MCP client, and using that MCP client, we have connected to the MCP server. And then we have, on after connection, first we have fetched all the list of tools, which contains the name of tools, the descriptions, and the parameters, and we have provided it in a JSON format to the LLM. Okay. So now what's next? So now when a user who is interacting with the chatbot, that will basically say to chatbot, okay, chatbot, now create me some 5 to do items around creating a job portal web application. So now the chatbot understands that the user needs to develop a web application for a job portal, and for this particular task, user has asked him to create 10 tasks. Okay. So now the chatbot will generate 10 titles, 10 description of those to do items, and now it has a context of what all tools are available, from which the one it has is a create to do. Okay. So it will create 10 different payloads and call the tools 10 times. Okay. And that tool will eventually call the REST API endpoint. So LLM has created the payload, called the MCP server. MCP server is having a function which calls the REST API server eventually. Okay. So now that API endpoint is called 10 times with 10 different payloads which are created by LLM. So now you would be able to see 10 to-do items in your database, which will have the 10 tasks related to web application development for a job portal. Okay. So now apply the same analogy to our first example of Airbnb. Okay. Now replace the endpoints of to-do application with Airbnb APIs. Now Airbnb, it might expose APIs related to fetch the listings of all the hotels or accommodations that are available, and it may contain the prices, it may contain the locations. There may be another endpoint which will be related to payment, third API which will be related to confirm the booking. Okay. Or the fourth would be related to send me details via email. So for all of these different API endpoints, we create MCP tool wrappers for each of those endpoints, and again those are exposed to our chat application MCP client. MCP client reads all those tools details with the tool name, description, what it does, and then based on the user query, it identifies which tool to call or which sequence of tools to call one after another to fulfill a user's request, and those tools will eventually call the APIs. So now your chatbot is able to do a booking for you on Airbnb using MCP servers. Okay, so this was a big picture of what we would be implementing. So now we can move towards our code. Okay, so let's start with the code. So now I'm at my terminal. I'll create some folders. Like as I said, we have three things that we need to make. We have to make a REST API service for Todo. We have to create a MCP server for Todo, and we have to create a MCP client or the chatbot. Okay, so let's start by creating the directories. First, let's create mkdir todo service, cd to do service, poetry init. I'm using poetry as a package manager here. I'm just doing enter. Okay, now after this I'll install some packages in this. I'll install poetry add uvcon and fast api. Okay, now I'll create a main.py here. Touch main.py. Now in this main.py, I have created this code which I'll paste here. What I'll explain you what I'm doing here. I have created this to do REST endpoints using fast API. I have created this pydantic model for to do, and this pydantic model for a create endpoint. Okay, and here I'm having a in-memory database. I will be storing all the to-dos in this to-do variable. I'm not directly connecting it into the database in this video, but obviously you can do it. Okay, and after this I'm having some endpoints. This is a get endpoint, get to-dos, which will basically uh, return the list of to-dos, and after that we have get to-do by id, and after that we have a third endpoint which is a post to do. This will basically create a to do. It will add a to do item into our list. Okay, and after this we have a put endpoint which is for updating any to do, and lastly we have a delete. Okay, so let's try to run it. Let's run it. I'm using the command poetry run uvcon main and main colon app because we have this fast API declared as this app, and the host would be 0.0.0.0 with port 9001. Okay. Okay, now let's open it in a browser. Okay. Yes, I've opened this URL on 9001 slash docs, and we can see, try running it out with a get request. We have executed. There are no items as of now, and this is a create endpoint, but we are not going to create it using the APIs directly. We'll create a MCP server. Okay, so now let's start creating a MCP server. I'll create a new terminal here. So now let's create a folder mkdir to do MCP server. I'll do a poetry in it. I'll add some packages. Poetry add, fast API, MCP, HTTPX, and uvcon. We'll require this MCP for creating the MCP server, and we would require this HTTPX for creating the for triggering the HTTP API calls. Okay. Now let's create a file main.py in this as well. Now let's open this main.py, and here you can basically see I've added a code snippet here. I'll start explaining this. I have used this fast MCP class from mcp.server.fastmcp, and using this class, I'm creating a MCP server. Okay, and as we know that our to-do service is running on port number 9001. Okay, so I have mentioned that endpoint base URL as fast API app URL, and after that, I have created this pydantic models. These pydantic models would be provided in our tool parameters so that LLM knows what type of input to pass. Okay, so now let's start creating our tool functions. As I said you earlier that we need to create wrappers around those API endpoints. So the first endpoints for get all to dos, I'll give it a name as get all to do and a description that it fetches all the to dos from fast API app. And this function, which is decorated by this tool, MCP tool, will be used by the MCP server, MCP clients. Okay, so in this function we are making a HTTP call which is client.get. Okay, this client is basically an object of HTTPX, async object, and it will basically trigger a get request onto our to do service slash to do endpoint. Okay, and it will basically return the final response that it received from the get. Similarly, we have other tools like this is a create to do, which basically is a wrapper on a post request of the create endpoint. So this is a client.post API call for slash to do. After this, the third is for a delete to do. Okay, this again it is a wrapper, but it will make a delete call on the to dos. Okay, this is client.delete. And lastly, we are running this MCP server using a transport SSE. Okay, so now let's run this server as well. We'll run a command poetry run python main.py in the MCP server folder. Okay, so it says that our MCP server is now active and running on port number 9002. Okay, so now the third step is now we need to create a chatbot and connect it to the MCP server. So I'll create a new terminal. I'll create a folder, chat service. Sorry, I need to first create this poetry in it. Now let's create a file, main.py in chat service, and in this main.py file, I'll add this code. Okay, so I'll start explaining what I've done here. Okay, so first I'm loading the environment variables from .env file. Currently here is no env. I'll need to add a .env. Okay, and I'll add the environment variables which I would be requiring. I would be using Azure in my case. You can obviously use OpenAI or AWS Bedrock, whatever you're comfortable with. Okay, so I'll add this environment variables. I'll hide this environment variables so my keys don't get exposed, but you can provide all the values in this file, and using the load env, all those environment variables would be loaded into your application. Okay, now that you have set your environment variables, first we are creating a fast API application. We are creating a HTTP client, and we are getting a values of the Azure keys from the environment into the variables, and we are now setting a variable which basically points to our MCP URL, MCP server. Okay, and this is basically a pydantic model which would be a type which we would use as a request body to interact from a front end to our chat service, where a user will send a prompt. Okay, After this, we have a function which basically loads the MCP client. Okay, we provide a config here, and this config basically contains a MCP list of MCP servers. Okay, in this case, we have named our MCP server as HTTP because it is fulfilling a HTTP request. You can name it anything. Okay, and after this we provide what is the URL for that particular MCP, and we provide any headers if we want to pass on. This is basically helpful if you want to have authentication and authorization enabled, and you can pass your JWT tokens in headers. You can basically carry forward it to the MCP servers. Okay, but in this case we are not implementing any authentication. And using this dictionary, we basically create a MCP client using the class MCP client dot from a dictionary. Okay, and this MCP client class, this is imported from a library called as MCP use. Okay, so we have to install this library. So let's install those dependencies. We'll use poetry add, and we'll install all these libraries: Fast API, UVCon, HTTPX, Python.env, LangChain, MCP, LangChain, Azure AI, and Pydantic. Okay. Okay. Now all my dependencies are installed, and that is all mentioned in this py project.toml. It automatically gets added here. Let's get back to our flow. Okay. So we have created this MCP client here, and we return it from this function, and this function we are calling from the setup agent, and this setup agent basically creates a MCP client and a LLM object from the Azure Chat OpenAI class. This Azure Chat OpenAI, this is imported from LangChain OpenAI, which we have just installed. Okay, and here we provide all those Azure keys with along with the API keys, the deployment names, and API version. Okay, and now we create a final agent, a MCP agent. So this agent is created using a class MCP agent, which is again imported from MCP use. Okay, so this MCP use library, it basically enables you to connect any LLM to any MCP server. Okay, like we would be creating our to-do MCP server, you can obviously create connected to a Airbnb MCP server. Okay. Okay, now that we have this agent created, we have passed LLM MCP client, we have said complete the request in maximum 50 steps, memory enabled is false, verbose is true, and we have provided a system prompt template. Okay, if you don't provide it, it will take a default template from the library's internal code. Okay, so this is an optional parameter. If you don't pass it, that is fine. After that, let's create one endpoint using the app object, which is created from the Fast API. Here we have created a Fast API object, and using it, now we are creating a normal endpoint, a normal post endpoint. So we name it as chat, and in the request, we provided a chat request type model. And if you see here, we would be expecting a request body of prompt. Okay, and after this, these two parameters are not being used. I'm just removing it. Okay, after this we are logging that there is an incoming request. After that, we need to give a prompt that what needs to be done. Okay. Okay, so here we'll say understand the user's question and use the tools to fulfill the user request and provide a final answer in a human readable format. Okay, and here we would be passing the request.prompt and incoming headers. These are the headers if we want to carry forward any of your headers. We don't want to carry forward anything, so I would remove it. And here as well, this function which we have created, it takes headers as well, but we don't want to pass any headers. We would just pass an empty dictionary here, and after this we the setup agent is called. Finally, from here we get the agent and we call agent.run, and we pass the prompt into that agent. Okay, this prompt is our instructions which we have mentioned here. Okay, now finally we run it, we get a response and we return the response. So now let's run it and see if by providing a user prompt, is it able to now connect to the MCP server and perform the create, update, delete operations on our to-do service. So let's go to the terminal. We will run it on port number 7000. Okay, now let's open this. I'll go to /docs. Okay, here we are having the endpoint chat, which we have created in our chat service, and we'll say that create 10 tasks for working on a web dev project for making a job portal. Okay, I'll execute it. Okay, it gives us a response that I have created 10 tasks for your web development project focus on making a job portal. Here are they, and it has provided us some list of those items. Now let's go back to our API service Swagger, and let's try to hit the get endpoint and see if those tasks are created here or not. Okay, now we can see that it has created 10 tasks into our database, which we have used as in-memory database. And these tasks are design wireframes, research job portal features, choose tech stack, develop backend, implement user authentication, implement search functionality, and develop front end, create job listing features, testing and debugging, set up project repository. So what actually happened here is, when you hit this request, this with this prompt, it got to your chat service. It took the request.prompt, it logged it here. We should be able to see that logs somewhere here. Okay, the terminal does not show all that logs because the limit has exceeded to scroll. But yes, it has created the final prompt with our user request and it has executed the agent. And what happened on the MCP server side? Let's open the terminal for MCP server. And in MCP server, we can see some logs. We can see that we got a request here for get when we triggered when it started making the connection from the chat service to the MCP server, and it has made some more requests for post messages. And after that we can see that it is making some logs related to calling tools, and it has called a tool create to do. Okay, so if we go to the MCP server and main.py, if we search this, we have this log tool called create to do. So this tool was called, and this tool then eventually made a API call to our API service. So now the request from here, it get again forwarded to this to do service. Here in this service we have this create endpoint which is named as post to do's, and from here it is first printing API called create to do. So if we go to the terminal of API service, this log should be there. Here we can see that it has this log printed for 10 times because we are creating 10 tasks. So this endpoint was called 10 times. Okay, Yeah, so I guess we have completely implemented MCP server. Let's try a delete task as well. Okay, so let us try to delete testing and debugging task. Okay, we will say that remove the task testing and debugging. Now what it should do, it should fetch all the list thought. Okay, has been successfully deleted. Yeah, it is giving a message that the task has been successfully deleted. Now first let's see if this task ID 9 is deleted or not. Let's execute this again. We can see that task ID 7, 8 and 10. So 9 is deleted. And if we go to the terminal and see what it has done, it might have fetched all the data from the to-do and identify which ID is having the testing and debugging, and that ID is basically deleted. So this is the MCP server. This is the MCP server. It has called get all to dos, and after that it has called the second tool, delete to do. Okay, and if you see the API calls, it has called get to dos. It has returned the 10 tasks. LLM has identified which task it is which we need to delete. It has taken the ID of that task and it has called this delete endpoint with that ID. Okay, so that's how you basically implement MCP servers and integrate it with your chatbot so that chatbot can perform actions that your user wants. Okay, finally, if you like this video, do subscribe to my channel. That helps me a really lot. Okay, I keep posting on the latest cutting edge technologies frequently, so stay tuned. Thank you.